Hello, everyone, and welcome back to Wayne's Code with Italians. Today, we are here with the last remaining ADB podcast host that we were missing. Tor, welcome.
Me.
Yay!
Hey,
Yes.
nice to be here.
New guest, as they're saying in the chat. Yes, yes, yes.
I have I brewed espresso today in honor of the Italianness of this podcast. I'm normally a latte person, but today espresso. So
Thank you, Tor.
here.
Appreciate it and
Thank you.
extremely culturally appropriate.
Good.
So today we're going to be talking about something that you love, I love, maybe not many others do, but we think
What?
many people
What?
should love, right?
Yes.
So we're going to be talking about Lint. I would imagine most people at least have heard of Lint, but I guess it's going to be a good thing to start from the beginning, explaining what Lint is and what it does and why you shouldn't disable it, because Lint is your friend. I've seen that. And also why you shouldn't ignore it, because again, Lint is your friend. And then maybe if we have time, we're gonna write a custom Lint check, because why not, right?
It's fun.
Yeah, exactly. So before we get started, Tor, I think everyone knows who you are, but do you mind introducing yourself?
Yeah, no, so I'm Tor. I grew up in Norway. And so I've been working on developer tools my whole career. First at Sun Microsystems for 14 years, and now I've been at Google for 13 years, also working on developer tools. And so I'm the engineering director for AndroidStudio. And I also was the original author of Android Lint. I keep saying Lint, but Lint was shamelessly stolen as a name that was kind of established in computer circles, right? So I think the first one might have been the one that went with the C tool, although it's possible that was also coming from something else, right? But so like linting is a general term for static analyzers, typically statically analyzing code. And it just seemed appropriate to call ours Lint as well. Although we do sometimes say Android Lint to disambiguate it, but that's really unfortunate now because it is not just used for Android, right? So inside of Google, they were using a tool called ErrorProne for sort of static analysis, and they had hundreds and hundreds of, well, probably thousands of checks to enforce conventions. But ErrorProne was deeply embedded in the Java compiler. And you couldn't really make that work with Kotlin. So they kind of looked around and realized that Android Lint fit the bill because it is deliberately supporting both Kotlin and Java, and you don't have to write the lint checks twice. And it's very rare that you have a lint check that only applies to one language, right? Unless there are other static analyzers for Kotlin, and that's great, and they can look for Kotlin language patterns. But if you, for example, want to forbid a certain call, let's say you can't call thread.sleep, you don't want that to only apply to the Kotlin code. You want to also apply to the Java code, right? And you don't want to write two checks and have two different suppression mechanisms and so on. So they looked around and said Android Lint looks good, and so now we're using Android Lint to do all static analysis on the Google code base, right? And even before the Google adoption of Android Lint as the linter, we had a bunch of people who were using it for their Android code, and many of the lint checks are not Android specific. For like some of my personal favorites are related to annotations. So you can, for example, say that this integer should be in the range, 0 to 128, for example, right? And then Lint will go and enforce any call to that API. If the value passed to the corresponding parameter is outside the range, it'll give an error. So we had people who were using these annotations in their Android code, and they also had server code or Java libraries used both on Android and elsewhere. And they're like, well, we want the same things elsewhere. Can you please extract this out of the Gradle plugin, please, or the Android Gradle plugin? So we did. And so that's why now it is really kind of a general static analyzer, despite the name Android Lint. So we'll just call it Lint today. But acknowledging there are other linters.
It's our Lint.
Yes. And we have actually gone through several attempts to name it. And, like whenever you open up to a group, people are like, hey, what should we name this thing? It's very, very tricky to come up with a name that everyone loves. So we haven't really gotten there. We really should do it because I think the name is kind of holding it back a little bit. Yeah.
So before we start, I think people that want to hear some more about Lint at the end probably should go and listen to the latest episode of the ADB podcast. I'm just gonna drop the link in the chat. I think that's the last episode with Chet as well, right?
Well, depending on when you
Ooh.
talk, 'cause we recorded another one yesterday. You know, we had a special guest host, Chet.
Oh, I see. Out the
So
door
we'll
in
see.
from the window.
It'll be our new Matt Damon running joke. Yeah. So we had did a podcast. Now that one we limited to just annotations because like Lint is such a big topic. Like there's no way we're going to cover it today either.
Yeah.
Unless we can go another 5-6 hours. I'm available if you guys are.
I mean, we can do part 2, part 3, part 4.
Yes.
That works.
It was a big topic. I mean, even, you know, I've done a couple of talks on Lint and every time I have to scope it down a lot, you know, so I am going to do a talk on Lint at Kotlin Conf this year. And I'm going to have to like limit it to like, well, Kotlin analysis with Lint, right?
Mhm.
But like when Lint started out, it wasn't even for Java code. The first Lint checks were all related to XML, right?
Mhm.
Because there was a tool that Romain Guy had written called Layout Opt, I think. It was like a Groovy script to just go and look for common patterns in your XML files. Like, hey, we don't want you to have more than 30 levels of nesting. That's bad for performance, right? So there was a handful of checks that were custom written. And, you know, basically pulling that into the IDE and sort of making it a bit more formal was the sort of the first beginning of Lint, right? Like applying XML checks. And this continues to be one of its core values, is that it is not, like I said, it's not just tied to one language, Java or Kotlin. It is really multidisciplinary. So you can have it run on XML. You can have it run on bytecode. It can run on icons. So like we have a bunch of Lint checks that are saying, for example, like for a notification icon, it should be a single color. Like it'll look for that, right? It'll look at grade properties files, Gradle files, and most importantly, you can sort of cross-check across the file types because that is a very common thing in Android, right? Is that, well, your XML file says that this ID is a toggle button, but in your code, you're casting it to a text field. That's an error, right? And that's the kind of thing that the linter will have to like analyze both in order to find those kinds of bugs. But those consistency bugs are really, really important. Sorry, I'm just going. Like I'm just gonna
No. It's fine. I actually had a
Yes.
question about this,
Yeah.
which is when you're talking about Lint supporting multiple file types, is that something that is pluggable? Could you theoretically add support for like YAML? Or I mean, I don't know if YAML is already supported. It probably is because of
It is actually not because we
TOML
easily should.
maybe
We added
is.
we added TOML support recently, right? Because
Yeah,
that's really relevant
because of
for
version
Android now.
catalogs, I guess.
Yeah, so it is not like there are sort of two APIs. So if you look at Lint itself, there's like the APIs are divided in half. There's the sort of the client API and there's the detector API. Now the detector API is the one that is meant for people wanting to write Lint checks, right? So you are writing your own Lint detector, right? And that has classes like the registration of what the problem is and your implementation of a issue registry and your detector and so on. Then there's the client API. This is meant for people who want to host Lint in their tool. So one of the key things about Lint is that when you're seeing Lint running inside AndroidStudio, that is not shelling out to a command line tool, passing a bunch of parameters. Lint is natively integrated inside the IDE with the client API, right? So for example, when a detector says, I want to report an error, you know, it just calls the client API, passing in a bunch of data. In the IDE, we will map that to, you know, a live editor and create like an underlined region, for example. Whereas when it's running inside a Gradle, it's going to be accumulating these things into a list, sorting them and creating like an HTML report and a text report, right? So having that client abstraction makes it possible for Lint to sort of be very natively integrated from in Gradle, in Studio, originally was integrated in Eclipse, and so on, right? And that abstraction is what, for example, lets the detector always work on live editor sources, right? So it like a detector should never ever read the source file from disk, because when you're in the editor, you want Lint to be basically like analyzing the character you just typed a second earlier, and we don't want to force save the file every time we like, run Lint, and we don't want to like create a temporary copy either, right? So basically, the lint infrastructure is called to the client and says, hey, I'm analyzing this file, give me the current contents, right? So
I guess
that's a client API, and that is not relevant to most people. The detector API, writing lint checks, that's really the part that is more intended for most people to know about. I will say I'm using the word API here, and I feel kind of like I have lots and lots of shame and regret about the APIs, right? Because they grew organically. And I you know, when I gave the first talk at the first Kotlin Conf in 2017 about Lint, I was like, oh yeah, well, here's what we're going to do for Lint 2.0, right? All the cleanup that I had like really wanted to do. Reality is that there's just a lot of uses of the existing API. You know, there are thousands of detectors inside of Google now. AndroidX has written a bunch of lint checks in their code base. Slack has a whole repo full of lint checks, and there are many others, right? And at this point, I could clean up the API to make it nicer and break everybody, and they probably wouldn't like that either. So at this point, it's kind of like, well, it seems to work. It seems to work. So we're going
to deprecate everything, Tor. Deprecate everything and give them, I don't know, a year to migrate.
Yeah, sure. Definitely is gonna happen. Yeah, I mean, it happened with Cobol, right? I mean, it happened with Cobol and Banks, right?
Yeah, it's part of the reason that this is difficult for us is that, well, we could freeze the lint APIs, and we more or less have. We try not to break them. The problem is that the lint API surface is much bigger than what we control. So when you write a lint check for XML, it'll probably continue to work in forever. Same thing with bytecode. By the way, this is not a promise. Just put that out there.
It should.
It's an estimate, right? But like, so for example, when you write a bytecode-based lint check, you're basically handed the ASM library, the well-known bytecode manipulation library. That's the API you use to manipulate the bytecode. With XML, you get DOM, right? These are pretty stable APIs, and so most likely the check you wrote today will work 5 years from now, most likely. When you're dealing with Java, and especially Kotlin, you're going into an API surface. One's called UAST, Universal AST, and one's called PSI. These are both IntelliJ and Kotlin APIs that are expressing the abstract syntax trees. You know, Java, you know, is not growing that quickly, but Kotlin is moving very fast, and the tooling is moving fast. And so these APIs are beyond our control, and they do change a bit. And so if you are dipping deep into Kotlin especially, and to do certain kinds of language checks, you kind of have to. Well, those checks might actually not work a year from now. So one of the things Lint does is when it loads your Lint checks, we actually go through all the bytecode in your Lint check, and we use reflection to see if that API still exists with the current embedding tool. And that's how we can catch that actually your Lint check's not going to work, and we'll disable it, right? So there have been some AndroidX checks that were doing some pretty specific, they were really hard coding to certain behavior in PSI that had changed. And you get this error, like Lint will report a warning saying this Lint check is obsolete, it doesn't work. We've disabled it, right? So there's still going to be some breakage that we cannot help. But generally, we're trying to avoid it at this point as much as we can.
That makes sense. The one thing maybe it's worth discussing the difference between, well, first of all, what is PSI, why we care about that, and second is what is the difference with UAST, and when do you need to care about one and the other or both? Yeah, I think that's something that is not entirely clear to me, because the last time I wrote a custom lint check, it was as UAST was starting to be looked into. So yeah, quite some time ago.
Yeah, so basically PSI is the low-level language modeling APIs in IntelliJ. Mm-hmm. And so PSI for Java and PSI for Kotlin are completely different. So if you want to do your analysis in PSI, you're going to have one code path for Java and another for Kotlin, right? So for example, you know, in Java, when you have a method call, it's called like I want to say a PSI method call. And in Kotlin, it's a KT call expression, right? So you're going to have to just have completely different implementations. And like, if you are writing something very specific for Kotlin, you're like, I want to make sure that when you have a companion object, you know, that you definitely are not using a property referring to a constructor or something. Like if you're doing something specific like that, it doesn't apply to Java. You're going to work harder if you do it in UAST than if you just go straight to Kotlin PSI. Mm-hmm. But the majority of Lint's built-in checks, there's like 400 or 500 of them now. The majority of them are not at the level of doing something very language specific. They are typically like, hey, if you call this API, you know, the third parameter has to do this, or, you know, it's going to be something where you really don't need to make it where you don't want to actually do it twice. Like UAST is going to give you what you want, because UAST, despite the name, it's not a universal AST. What it is, it's the Java view of
It's a
your
universal
code.
asterisk.
Yeah, I think it started out as that, and that was my understanding initially. And it would be
Yeah.
nice with like a superset, but like to make this concrete, UAST does not have properties. For example, what happens with your Kotlin code that has properties? Well, if you've ever gone into a Java file and try to access your Kotlin code, you'll see that your property turned into a getter, a setter, and a private field. That is also what you see in UAST. So when you have, var foo in your Kotlin code, UAST is going to give you the private field and the getter and the setter. Now, for UAST, one of the nice things is you can also ask each element for its original source element, right? So you can typically, and many lint checks do this, you can do most of the analysis in UAST, and you can dip into specific language PSIs and some PSI elements when you need to. But so the key thing is that if you can express your lint check as what would the Java compiled, not bytecode, but sort of the Java pseudocode of your code, what does that code look like? Can you express your analysis that way? Because after all, that is what Kotlin will do. Kotlin C will take your property and it's going to turn it into a getter and a setter and a private field, right? And so it's typically possible and realistic to write your lint check that way. Another thing that lint does is it has support for quick fixes, right? And these quick fixes can be applied either on the fly in the IDE, maybe we'll attempt to write one today, or sort of from a batch invocation. We have a special Gradle target for running all the safe fixes. And quick fixes is one of those things that is not realistic to do in a universal way, right? So it's very common that when you write a quick fix, you'll be like, okay, if it's in a Java file, here's the fix I want you to do. And if it's in a Kotlin file, here's this other fix. And that's just what you have to do today, right? There isn't some good way to express rewriting the code in a language neutral way and have it insert the details for you. But in practice, this hasn't really been a problem.
I see. Yeah, I remember that the Lint API way back when the rule APIs, they tended to change quite a lot. Are they more stable now, or because of all the usages you mentioned, or are they still evolving?
The biggest thing that changed was the API for Java code, right? So originally, we didn't have a Java parser that we could use. It just, Java C was something that we didn't really want to touch. This was, I'm not going to get into why, but it was just like let's not touch a Java compiler in the Android Lint tooling, right? So we used something called Lombok, which is an open source project, probably still exists, right? But they had their own they were doing their own lightweight parsing at the time. And so we used that. So we got like the basic shape, like they were doing basic lexical analysis and some parsing, right? So you kind of got an AST, and it was good enough for Lint's purposes. But one of the things it was missing was proper type attribution, right? So when you have a method call, figuring out exactly what is the receiving method, that is pretty tricky, and you need to get it right. Yeah. And it didn't do that, right? And so originally, we did a lot of lint checks were written in bytecode instead, because when you look at the bytecode, the compiler's already run, and so you have full type signatures for everything. So like the original API check, which I think is maybe the most important lint check we have. So briefly, API check is for Android development, where every call you're making is sort of checked against the database to see like, is the minus decay in your app, is this safe to make? And there are so many corner cases you would not believe, right? But this is a pretty complicated check, and it's sort of vital safety net for any Android developer. That one was originally written in bytecode, with bytecode analysis, because it had to know exactly which method call are you making. We couldn't guesstimate that. So a lot of lint checks that needed type attribution was done in bytecode, and we had sort of a lightweight Java parser from Lombok that we used. And then we migrated from that. And, I really wanted to be able to have lint checks run the same in the IDE and on the command line. And so there was PSI. Like PSI was available inside the IDE, but not outside the IDE, right? And so I actually implemented a complete bridge from PSI mapped by the Eclipse compiler, ECJ. So this is a pretty big API surface. And I remember, I had a lot of fun with this. Like basically like running ECJ behind the scenes and then mapping all the ECJ classes to sort of wrapper PSI objects. This worked kind of well. So now you could do PSI, Java PSI, because Kotlin was not yet supported by our tooling. And so you could write a lint check using PSI, which was a nice improvement. Now you had type attribution. And again, we could do the resolving because behind the scenes, ECJ was also doing correct resolution. But think about it. All the lint checks were now sort of invalidated because this is a complete different API surface. And this is around the time that we started talking to JetBrains about Kotlin. Android had not adopted Kotlin yet, but Lint was probably the first tool to actually add support for it, even though we weren't officially supporting it, because there were many Android developers who were using Kotlin despite no official support. They were happy, they were productive, and they wanted Lint, and JetBrains wanted them to have Lint. So JetBrains started looking at UAST at the time, and they wrote UAST, and then I helped on my end to sort of adapt all the changes we had done since and to kind of merge this. And so then we had another switch to UAST. So we've gone through multiple generations of parsing APIs, and these are incompatible, obviously, right? And those were the big breakages. There's been other breakages too, but much more minor. Like those were the hard ones. But I feel like at this point, we've been pretty stable for a while. Modulo, especially the Kotlin PSI, which is continuing to change, and it's going to change. By the way, spoiler, it's going to change a lot again. Right? There's something called K2 coming, the new compiler front end. It's going to give us fantastic performance improvements, and it's going to be more supportable. Like they've rewritten the front end to sort of be not just faster, but also more maintainable and so on. And so there's a new API called the Analysis API that really is a better way to deal with Kotlin details. And we already have support for this in Lint, and a lot of our built-in checks have switched to it. But if you're deep in Kotlin PSI, this again might be another one of those things that change. If you use UAST, there's no problem. That'll just it'll port over, right? But whenever you're deep in the details of Kotlin, that is still an unstable API surface.
Yeah, we have a couple of questions about this actually in the chat. One of them is if with K2, the APIs should become a bit more stable because there should be a stronger contract than there used to be.
That's right. So that is what my impression is. The Analysis API is exactly that, right? Like it is something that works both in the IDE and on the command line. In the past, doing type resolution was very tricky using PSI, and now you have a much cleaner way to do it. So yeah, the Analysis API is a good way to do this. So now it's still being developed, but it's getting pretty close. We ported a lot of AndroidStudio functionality over to, like I said, all the built-in lint checks are already using it, and we've been busy sort of porting, like Studio Bot and Live Edit and a bunch of other areas that we're doing Kotlin-specific things over to the Analysis API. So this is going to get better, and it's happening this year, like a lot of this.
Yeah, I mean, Kotlin Conf is getting close.
Yeah.
So the other thing is they're asking is, if this could help KMP support as well. So
yes,
I don't know if I guess that API, the Analysis API, would be supporting KMP.
Yeah, I suspect it does, because it's really a front end API, and KMP should be sharing the same front end. So like
different backends.
Yes, and we are working on Lint working with KMP as well. So
that's nice.
Yeah. No, it's one of we are sort of flirting with KMP, right? So even though we don't officially support it,
That's the official position. We're flirting with KMP.
It's the same thing that happened last time, and I'm not projecting anything, in the future, right? But we thought, hey, there are some developers who want this. Like, let's make sure that Lint works with Kotlin, right? And so again, there are people who want to apply the JetBrains KMP plugins and so on. And and they want lint. And so, we ought to make that. It kind of goes back to the whole, like, it should not just work for Android. Like there are people who are finding use for this. And so we want to make sure that lint works for that. There's really no good reason for it not to work.
So I guess
other than it's a small amount of program.
it already kind of works for the internal Google code base outside of Android projects. So
That's right.
The idea is that we want to have the same in a general capacity.
Yeah, it's a useful tool. I mean, on top of the code analysis, there's all these other things that Lint does. That, for example, there's a lot of support for suppression. So like baselines, right? The ability to sort of record all your current warnings and sweep them under the rug, right? But like basically, you can sort of enforce from now on new things.
Yeah.
Right. It kind of gives you a good way to roll out new checks without like having to fix all your existing debt. All the support for using comments or annotations, including in XML files, right, to suppress things. There's special configuration files like the lint.xml files that you can use to suppress things using regular expressions, for example, right? Or it has an API for supplying options to lint checks, so you can make your lint check take, for example, a config file, and lint will pass that to you. So there's all these other things that makes it kind of a useful base to create local lint checks for your company on top of, right? And the quick fix functionality also is kind of handy, right? So for all those reasons, it seems important to us to make it not just tied to Android, but make it generally useful for Kotlin, because we are pretty serious about helping Kotlin as well. We have people on the Kotlin Foundation board and so on. And so, beyond Android, we want to make sure Kotlin's successful.
And we write Kotlin every day.
Yes.
It's like we working. I haven't written a line of Java in I don't know how long, and I'm happy about that, to be clear.
And it would be fun. Like maybe we can write the lint check in Java today just to see how much we stumble.
Oh, please don't.
No, it was a joke. I am not willing to do that.
I mean, otherwise you have to go back all the way and go and do it in Groovy like Roman did.
Yeah.
But I'd rather Java at that point.
Yeah. Well, the funny thing, one of the first things I did when I joined the Android team was I rewrote a bunch of Groovy code back to Java. It's not that I have anything against Groovy, but it's just the developer experience was terrible because we had worse debugging and all these things. It's like this was nice, but we don't need the flexibility we got, and we really need the performance. It was like a 5 megabyte runtime too, which at the time was kind of a big deal.
Yeah, Groovy is nice. It's just almost impossible for tooling to properly support it because of its nature.
Yeah, I am a big fan of statically typed languages. The older I get, the more convinced I am.
Yeah, I think it's been less than 1 week since the last time I've stated that dynamically typed languages are the spawn of the devil. So I agree.
I've been playing around with TensorFlow recently, and Colab notebooks and so on, and it's all in Python. And I struggle so much because like I'm kind of exploring these APIs just to kind of learn them. And I have a data set and I need an input tensor, and I'm going like, IDE, please help me, right? And there's just it's Python.
Yeah.
And I struggle with that. I'm sure for Python developers, this is easy and obvious, but for me, one of the nice things about statically typed language, especially when it has good tool support, is just the tools just help guide you towards the right thing, and you can explore the API surface.
Yeah, it's much, much easier to figure out what you're supposed to be doing when you cannot do the wrong thing, or you cannot do a random thing. Yeah. And then only find out at runtime that, oops.
Yeah.
So we have a bunch of questions in the Slido, so maybe we can start taking some of them. First one, let's go from the oldest to the newest. Hugh is asking, how can I make sure that the warnings in Studio match the warnings from linking tools in CI? I probably meant linting tools.
Yeah, so one of the tricky concepts in Lint when you write a Lint check is understanding analysis scopes. But the easiest way to think about this is that some checks require global analysis, and we can't do those on the fly. So if you think about something like unused resources, You know, when you run lint on the command line, the unused resource analysis will look at all your resource declarations across the entire code base and all the resource usages. And it'll basically figure out that, hey, this one resource over here is not consumed anywhere. And then we can flag that for you, right? And that check, you know, is not something we can do on the fly while you're typing because it requires looking at everything. You might get the impression that it's possible because IntelliJ does something very clever. You might have seen that in IntelliJ, sometimes it'll say this global variable is unused. And you're like, how did it do that on the fly? And the reason they can do that is they have an index, which is basically they're tracking all names, and they track whether it's a read or a write, right? So if they can look at all the names of sort of declarations in your file, and if they see that that name is not read anywhere, they can like show it in gray because they know it's not possible. But if you have that name colliding, so the name is used, but it's a private method somewhere else, you know, so they're unrelated, but the name clashes, IntelliJ cannot do it, right? So this is like, it helps in some cases, but in general, they cannot do global analysis on the fly. And so the delta that you should be seeing today is that some lint checks are not running on the fly in the editor because, again, when you write a lint check, you can indicate whether or not you are capable of running on the fly. That's an analysis scope. If I say I only require the current file as my analysis scope, Lint will run it in Studio, and there should be no difference between the two. But again, there are more checks running on the command line because, well, there we can take our sweet time looking at everything, right? That we just don't want to do in the editor. And that should really be the main difference. Of course, you know, there could be differences in like which Kotlin plugin you have in the IDE versus what Lint is running with. Right, so there could be some deltas there, right? Because like when Lint runs an IDE, it's going to be running whatever the Kotlin plugin, however the Kotlin plugin chooses to parse your code and so on, right? So there's maybe some small deltas, but in general, the CI should be a superset.
It's kind of fun because Maya in the chat was saying, so that's what it's doing when it's indexing.
Yes, yeah.
Yeah, indexing is a mysterious, long, time-consuming process that I think we can fairly say a good chunk of things in the IDE would not work without.
It is the secret sauce in IntelliJ, right? It's very, very clever. Now, again, I think we all have our frustrations with like corrupted indices and so on, and we kind of wish those were going away. Invalidate caches, you know, is to me still kind of it's sad that a product has exposing caches as a top-level concept. But it is tied to so many fantastic functions. That's hilarious. Yeah.
You want one of those stickers?
I really, really should put it on my laptop. That would be funny. You know, it is one of those things that we can't live without because it is enabling so much, you know, magic. And it's tricky for us because I don't think we can really do it in Lint. You know, it would require looking through the entire source base twice, right? First indexing, because you don't know the order in which you're going to index things. IntelliJ gets away with it because, you know, they have this persistence. It's not happening every time you start the IDE, right? But it's harder for Lint to do that.
And I think the other thing is that, yes, caches and indices sometimes break. But caching is a very, very difficult thing to do, and especially when you need to cache not just the names, but you know, types, locations, relations with other things. It's a very challenging thing to do, and the fact that the IDE can index, you know, hundreds of megabytes of symbols in, you know, 30 seconds and know what they do everywhere, where they're used, how they call each other, that's, to me, is extremely impressive.
Yeah, part of the reason it works so well is that they're clever in what they index, right? So yeah, you might have, like, if you do find usages in IDE, you'll notice that it's still thinking after. So what it does is it uses the name index we just talked about to figure out, well, which files could possibly be affected here, right? So if I'm doing find usages on like get address, it's going to look for get address in the name index, and it's going to find that 17 files are mentioning it. It's going to reparse those 17 files because they don't have a complete index of like all method signatures and all those things, right? Those would be hard to keep up to date. but they're using the name index to sort of make that lazy parsing much faster. And that's why if you ever do find usage on a very common name like create, it's much slower, right? Because it's finding a lot more hits in your code base because of this. Yeah, one of the things that used to happen was that every time we had one of those like fireside chat things at Google I/O or AndroidDev Summit, people would ask, "Why is Lint so slow?" Right? And
is that after why is Gradle so slow?
Lint was people complain even more about Lint because Lint is one of the slowest tasks in Gradle, right? And my defense was always like, well, we do more than the compiler, right? Like we do the same costly thing. The front end of the compiler has to run, but then on top of that, we're running hundreds of analyses, right? And so on. And so it's natural to me that it's going to be slow. But one of the things that people complained about was that there was no incremental caching. And that's something that we've actually added in the last, I want to say, year or two. There was something called partial analysis, which was a big, complicated thing for us to do, right? Like if you have a library, and in that library, you are making a call that requires a high API level. But downstream in your app module, you set the min SDK to something even higher. You no longer need to complain about that, right? And so what we did with partial analysis is when you're analyzing the library, we report these warnings, but we put parameters in them. So we're saying, for example, hey, here's this warning if min SDK is less than 25. And then downstream, we can use that cached result from the library, load all those things without recomputing them, and just like applying the parameter filtering. It's a bit of a reduce, algorithm. This was a big thing for us to rewrite a lot of lint checks and rewrite the lint integration and the thing you just mentioned, how to create all the right inputs, how to model all the right inputs so that Gradle can do the right thing. But we got this done. And people have noticed, right, that Lint actually is a lot more incremental now. And so, that's something I'm pretty happy with. And we don't get a lot of reports of like the Gradle cache being corrupted, right? So this seems to work pretty well.
That's always nice. Yeah, in the meantime, there was a bit of a discussion in the chat about previews. It's completely unrelated. I think that I should probably ask Diego or someone to come and talk about how previews work, because that's a whole different thing.
Preview machinery, like I, used to work, I used to code, and so early on, in the days of providing previews before Compose, right? The stuff with layout lib, like running a fake Android environment inside a desktop VM is quite a technical feat. And the stuff that Diego and his team has accomplished is pretty amazing. So I think that would make for a great podcast.
Yeah, next time I'm in London, I'm gonna bug them.
Yeah.
Let's take the next question. I mean, we've kind of answered that already, but Lint already works on non-Android plain Kotlin projects. Any chance that it could support KMP2? I think the answer is eventually.
Yeah,
we're flirting with it.
No promises. No, I mean, we are definitely working on KMP support. No promises on when it'll land, right? But it's definitely something we want to do and I'm working on.
Awesome. Next question from Maya. I wrote some custom lint rules in Kotlin to look for hard-coded colors in code. Will these custom lint rules need a lot of change when I move to K2?
For hard-coded colors, it seems to me like that should all be accomplishable via UAST. Like I don't see any reason why. Like you can implement the lint check in Kotlin, and one of the things I'm proud of is like we have a bunch of lint checks that are checking your lint checks. Who polices the police?
It's lint all the way down.
That's right. And one of the things I did was like, if I see a lint check and it's written in Java, you get a lint error, right? And and saying you should be running this in Kotlin. And it's not just because I'm biased against Java. It was because basically like Lint is deliberately using Kotlin mechanisms like default parameters. So like we have some Lint signatures that have like, I want to say 20 parameters, right? And you wouldn't, and all with defaults. And you don't really want to be using the Java signature because again, we might add one more. And your Kotlin code will recompile just fine and your Java code will not, right? And so basically kind of encouraging people to use Kotlin was good. Now we had a bunch of existing Java checks, and so the magical trick, maybe I shouldn't say what the trick, well, actually it's open source, you can tell it. The trick is it looks at the copyright year. And if it sees that the lint check was added after 2020 or whatever, 2019, I don't remember, then it's gonna say, you shouldn't be running a new lint check. And this has actually been useful because we've had other partners at Google contribute lint checks, and they weren't aware. Like their team is using Java in their day-to-day work, so they're like, "Here's a great lint check," and then they upload it to our CI. It runs a pre-submit checks, and they're like, "Do this in Kotlin." I don't have to be the bad guy. The lint check is the bad guy.
I see. Tooling as a way to just shift the blame to the machines.
And this is a very, very easy lint checks to implement in your own companies, right? It's trivial.
Yeah. Maybe we can have a lint check that just errors out regardless if it sees anything that is not a KT file.
Yeah, I mean, it can be done. So the thing is, like, you have some existing stuff, right? So like tying it to copyright seem reasonable, or you could use baselines as well, right? If you want to force people going forward to follow a certain convention.
Yeah, I remember when lint baselines were introduced, I was like, but why would you need just get rid of all, like, fix everything. And I was like, I was young and naive.
And then you saw our code base.
I was young and naive. But then,
the baseline part is crucial. Has been crucial for me as
contractor.
Freelancer. Also, yeah. I mean, even when you, because Detect does something similar, right?
Yeah.
So I join a team, I set up the CI, I set up the linters all over the place, and nothing builds anymore.
So is your first day on a new client being like, so folks, the party's over?
No. So the first day is, how is everybody? Ivan, it's a funny guy from Italy. Yeah. Second day, strict mode, KT Lint, Detect, Android Lint, and then that's how you make friends, right? So when at some point, and but no, I'm a huge fan of the baseline, because from that point, as you said, you just draw a line and you say, okay, now we have 200 warnings here. Either we stop for 6 months, or we acknowledge the fact that we already have 200. From now on, no pull request basically passes if you add more than 5. Because people are also used to work that way. So you can say, oh yeah, 0. No, from now on, it's 0. You have to have a tolerance kind of buffer window where you just train people to let fewer and fewer. But then at some point you can also start addressing the baseline part, right? You try to go, especially when you put things like Sonar Lint in place. And the dashboard in the passive aggressive dashboards on the TV in the office, that kind of
the thing that is all red when you start.
But that's the classic thing when the CTO comes to you and say, I would like to see numbers, the quality of the code. And I was like,
no, you don't.
you have no. So can we have like an idea how many crashes we have in production? You don't want to do that, and we'll Lint say, oh, it's the text coverage. Those are the things that you don't want to know anything about, because otherwise you just start. But again, I love that kind of stuff. That it's in place. We acknowledge that we have issues. They are there. From now on, we kind of try to improve.
We're trying to be better.
Yeah, but that's so.
Go ahead,
please.
One of the deliberate choices we made is that when you are opening your files in an IDE, we ignore the baseline. And the point is, if it was really swept under the rug always, it would never be fixed. And so the idea is, yes, your CI can enforce no new errors. But when you're looking at a file, we kind of want you to say, oh yeah, I could fix that while I'm here, right? So it's one of those things that I think is probably a good call. And baselines are also vital for us, right? When we roll out a new lint check, especially if it's kind of, guidance-oriented one, right? That might have existing violations. It would kind of be blocked. You can't turn it on as an error if you couldn't say, okay, well, this is a new thing we're instituting, right? The way that this happens inside the Google code base is a massive code base, right? And so like these lint checks would never be turned on if we couldn't also just like at the same time check in updated baselines.
Oh yeah, let's update link. What could go wrong?
Yeah.
And now you have 300 errors, and I'm like, this is gonna be a long week.
Oh yeah. So like 300,000. Yeah, no, it's crazy.
Yeah, no, but just in my project, right?
Yeah.
I'm thinking in my.
Yeah.
But you know, I like the fact that you see them, even if they are not ignored, but let's say baseline under the rug kind of thing. You see them when you open a file, and you will be surprised, or you won't be surprised how many pushback I get with this kind of fix. Right, that's the classic one, right? So you open a file and say, "Oh, this is tiny," tuck, and then you commit the thing,
Yeah.
and people bashes you on GitHub because, "Oh, that doesn't. It's basically pointless for this PR. Can you split the PR?" And you're like, "Say, man, I'm just fixing this tiny thing. Can you?" You know, but that's the part of the game.
It's a philosophy thing, you know, where I'm probably I'm the kind of person, I'm sure it's a nightmare to review my code reviews, because I basically will work on a bunch of things, and while I'm there, I'll fix other things. And to me, I don't actually love getting a stack of 15 CLs that are like independently like working their way up, you know. And I feel like this was
I know you're talking about mice.
Yeah, Seb is feeling personally attacked, but like you know, yeah.
I'm reading this. I don't know if you're familiar with this one. This is the latest book from Ken, and it's beautiful, right? It's tiny book. Every chapter is like one tiny. It's not even a refactoring thing. It's just, you know, like a quality of life tiny fix that you can do. Every chapter is, man, I will get so many. Even what the fuck with this? Because this is what I do, right? You see something tiny. Oh, like, you know, and then you clean up. It's like Marie Kondo kind of thing, right? You just fix it one time, and it happened so often in my career. Like, oh, this is not related to the task, and
no, like, there are people who push back for sure, you know. But to me, a stack of CLs does not spark joy.
Yes, but actually, because, you know, that's the mythical microservices swarm that's actually just a distributed monolith, right? Those are not separate CLs. They are just one CL that you just split because you have issues, but I can't actually pick them, you know, singularly, because maybe the next one is actually based on something that I wanted to fix before. So it's a chain, right? So you have, if you have to review them,
separate, why not? But often there's a little bit of an overlap between two things, you know. And so like my commit messages are essays, usually.
Yes.
The other thing I wanted to mention on baselines is we recently added this facility where it is reality that sometimes you want to change your error message, right? Like you have a lint check and you want to update the error message. And with a naive baseline matching mechanism, like that would break. And now like everyone's baselines are wrong, right? And so for the built-in checks, we had actually hard-coded some of those switches. Like, okay, I mean, it already does some basic smart matching. Like if you just append something, it's going to be like, that's fine. You're just adding more context, right? But we've now made it so that every lint author in their detector can also override the baseline message comparison thing, right? So you can say, actually, yes, this is the old message, that's a new message, this corresponds to the same thing. So that, you know, you can also update your message to be better without invalidating a bunch of baselines.
Right, because it cannot just check by ID, it needs to know what the problem actually is to be able to distinguish them.
Yeah, one of the guidelines that I think is very, very important is when you write a error message, try to include details in the error message. So like, I'll give an example. You don't just say unused import, right? Because there could be 7 unused imports in that file, right? And if they all just say unused import, how does the baseline mechanism match which one you fixed, right? Like, even though if you look at a baseline, you'll see we include like the line number and some other context, we don't actually use the line number. The magic is we match by error message first, and we kind of do them in order within the same file. This works best in practice because it deals with the case where you moved some code around, which we don't want a baseline to fail just because you transpose 2 lines, for example, right? So by making sure that error message always includes specifics, so in the unused import case, the error message should say unused import android.app.activity. Right. And so that one, because it's like anchored to the content, right? It's going to be more uniquely identifying the real error. So if you delete some other import that happened to be first or on that line now, it's not going to be confused, right? So that's how it works. And that makes the error message matching very important, right? And that's why this is now configurable.
So we have another question, which is kind of somewhat related, which is Stylianos is asking, is saying actually, my problem with writing custom lint checks is finding the right API. I usually look at samples, but if the samples don't do what I want, I am lost. Do we have resources that we can point people to? I guess the built-in, there's like 800 built-in checks.
I think that there's a couple of things, right? So I think people usually get stuck on the actual abstract syntax tree. So let's push that on the stack. Right? We're going to get back to that. In general, even when I write new lint checks, will typically go to an existing lint check, clone class, and just start changing it, right? Because it's a faster starting point than a blank canvas, right? And so there are, like I said, there's 400 to 500 built-in lint checks, right? And so often there's going to be something related, right? So if you're doing something with annotations, for example, right, you might go like, well, doesn't lint have some lint check related to annotations? Okay, let me go look at the one that deals with visible for testing and just see what it did. Like, oh, you're overriding these 3 calls. Great, I know what to do now, right? And so the built-in ones are pretty useful. And of course, there's a few lint utility classes that are loaded with stuff that is useful, right? So like kind of looking at our lint utils class and the testing utilities class is useful. But of course, the built-ins will often call those. Now, the biggest problem typically is the AST, right? So you're analyzing some code and you're like, well, how do I find out what to look for? Like which AST elements, or, you know, if I'm looking for the pattern foo.bar.baz, how do I find out what the foo part is called, right? And so the trick there is to do test-driven development. And I'm a huge believer in test-driven development, especially for something like lint. It is harder, like, so Seb, you work on StudioBot. It's harder to do test-driven develop or something like that. It's possible, right? But for a command line tool that has inputs and outputs, I always start with the failing test. I go like, okay, here's the sample file, and I want to actually analyze this. And so I basically put the sample file that's going to be analyzed into a unit test, and I run I call the lint fluent API to like run on this and then expect an empty string. It's not going to return an empty string, but now I'm going to get a failed error message, right? And now I can set a breakpoint inside my debugger and run. And inside my detector, I'm looking at the callback, right? That hands me, you know, an AST element. And there is a very useful API called as recursive. I use code completion, so I don't remember the suffix, right? But like you call UAST element dot as recursive log string, I want to say. That'll basically dump out the UAST with all the class names and nested trees. You can see, oh, we have a U method, and inside there's a U variable, and then there's a, you know, U call expression, and that takes a U parameter. So you can kind of see what the names of these things are. Or you can just in the debugger start, you know, like actually saying, you know, expression dot UAST parent to walk your way back up, right? So you can use the debugger or this dumping method to find the UAST elements. That's what I do, right? I know some of these things after writing a good portion of those checks, but also like, especially when you deal with Kotlin, when you get into the Kotlin PSI, like you're trying to do something really unique to Kotlin, you know, you want to look at a coroutine something. Okay, write the unit test and then get in there and call element.source PSI. Now you're in the Kotlin world, right? And now you can start looking around, you know, with get qualified name and so on.
There's also a tool in the IDE that is the PSI viewer that you can use. That is maybe easier for like smaller things where you have no idea. Oh, if I change, you know, if I tweak this small thing, how does the AST change? How does the PSI change? I've just linked in the Twitch chat the documentation page for that.
Yeah, I'm under the impression that you have to turn the IDE into internal mode to get it.
It says that it will be available when there is at least one plugin module defined in the project. If you want to always have it visible, then you need to enable idea.is.internal.
What is a plugin module?
So essentially, if you're writing a plugin, I think.
Oh, IntelliJ plugin. Okay, yeah. So you wouldn't be typically when you're writing a lint check, right? So like unless you apply the dev kit, turn the IDE into internal mode, and then you're going to see all kinds of crazy stuff.
Oh yeah.
It's the longest context minute in the IDE. I think it wraps.
Yeah.
Right. It's a.
It scrolls on Mac. Yeah.
Yeah.
It's longer than the screen for sure.
Yeah.
There's all sorts of things you should never really touch unless you really know what you're doing. I think my favorite internal action is crash. It's like just causes a crash, throws an exception. It's like,
yeah. Well, it's one of those things when we want to test, like, hey,
Yeah.
are we handling this? You turn this on.
Yeah,
I
it's
think
like-
internal mode might make something slower as well. So use at your discretion. But yeah, that's another way to do it.
Yeah, probably don't need to leave it on all the time, but if you are developing a lint check, it can be very useful.
Yeah, but like I said, most of the time you want to operate in the UAST space, not
Right.
the PSI space,
Yeah.
right? And so the as recursive log string, I think that's going to be your best friend.
Then the next question we have, is a custom lint rule a good option for checking if Gradle dependencies are sorted in the preferred order and providing a quick fix to sort them if necessary?
Yeah, I mean, I would say the correct way to do it now would be a version catalog. Like we're really getting away from the, although I guess you still have the reference, and if you care about the order, but it's strange that you would want alphabetical order for dependencies, maybe. But yes, you absolutely can do that with the lint check.
Unless your Gradle script is in Groovy, I guess.
Nope.
Do we also
have
support Groovy?
Yes. In fact, we supported Groovy before KTS, right? And
Makes
one of the
sense.
nice things about using lint for this is that we have, it's not, again, this is one of those regret APIs, right? Is that, for Gradle, we didn't really want to make it possible to do like crazy code analysis of like if-else blocks inside your code, right? It's really doubling down on the whole dotted notation. You can write Android lambda or Android dot, right? And it kind of treats these as equivalent, but when you have DSL blocks. And so there are callbacks there's a couple of callback mechanisms when you say, my lint check cares about Gradle. There's some callbacks that are saying like, well, if you have this property with this like parent and this parent, here's the context, right? And so you can look at our Gradle detector, for example, which is a massive class, way too long, embarrassing, but it's doing a lot of this stuff, right? And the nice thing is that we have both a Groovy backend and a KTS backend, which will map both build.gradle and build.gradle to KTS to these same callbacks, right? So we have a single, all the lint checks you're getting for Gradle files, will work for both transparently. There's no KTS, there's not much KTS specific stuff in that detector because again, we kind of handle that abstraction layer.
And we have the last question for now, and then we can start writing our own custom lint check. Just a weird question. Is it fine to use detect and lint or KT lint together? What might be the negative side effects? No,
I don't think there's any issue with that. Like I said, I'm suspecting, I don't know a lot about these tools. I used KT lint for years for formatting not for analysis, but for reformatting the source code until we sort of switched over to KT FMT.
Yeah.
Recently. But I assume that those checks, given that they are Kotlin specific, I'm assuming they're for Kotlin programming conventions, right? So they're probably going to be more for like, hey, in our Kotlin files, we don't want you to use var when you could have used val, for example, right? I'm guessing it's stuff like that, right? And so
mostly, yeah. There are some performance related things in detect, but I think the worst thing that could happen is that you might have multiple tools flagging the same problem.
Yep. That was one of those original things like Android Lint, like we didn't want it to do general programming analysis because it was just going to duplicate all the warnings you already got from Eclipse, right? So it doesn't have a check for like, oh, this comparison is really an assignment. Thankfully, Kotlin's kind of fixed that already. Like we didn't do that. Now we have branched out since then and done really more generic checks. But yeah, you might have some duplicate warnings, but I mean, those should be easy to deal with, I would think. So, I even before, we supported AndroidStudio and IntelliJ, I would often use IntelliJ even as an Eclipse, even while I was developing Android tooling for Eclipse, because it was giving me additional warnings, And so like, why not get more advice,
I started using IntelliJ as soon as they started supporting Android, because
Yeah.
Eclipse
The only thing that
was
might suffer is
Eclipse.
your build times, right? Like there's a cost to running additional
Yeah.
parsers, but if like especially maybe not on CI, but at least regularly, check what they have to
Yeah, I guess if you have like Detect and KT-Lint tend to be very quick, especially KT-Lint, because it only looks at the text. It doesn't really try to understand much. Detect can be slower because it can do type analysis. But the way I set things up generally when I work on a Kotlin project is that I have Detect and KT-Lint and Lint, if it's an Android project, run on a pre-push hook. So before pushing, just Git runs the Gradle task, and that if you have run the check task before, it's very fast because it's incremental anyway, so it's not a big deal.
Yeah.
Sometimes,
So
you get the same complaints from multiple tools, but that's fine.
Yeah. I mean, you just said if it's an Android project, but again, there is a Gradle plugin, com.android.lint, which is an alternative to com.android application or com.android library, which will give you the lint tasks, right? So even for a non-Android project, you can apply the lint plugin. It should work.
I really should. I should apply to Jewel and see how many lint errors I get on my Compose usage. Would it
Yeah.
pick up Android X lint checks as well?
No, I don't think so. Part of the difficulty, so what lint does, which I think is great, right, is that it lets you bundle lint checks with your libraries, right? So that like if you have a library, and I remember like Jake Wharton's Timber was one of the first ones who did this,
Yeah.
right, externally to us, right? Like here's my logging library, and here are the lint checks that checks your usage of our API. So you could sort of have lint checks that are enforcing what comes to the library. AndroidX does that now. The problem is Maven doesn't support that, right? Like Maven dependencies are just, here's my jar, here's my production code, right? In Android, we created the AAR format. Like it's a zip file that has code and lint checks and resources and ProGuard rules. Like we basically created like this bigger payload. That is what we're piggybacking on for lint checks. And that, I don't really think that works outside of the AAR world. And so I doubt that this would work. I'm not sure, actually.
So I know the way you can add additional rules with like Detect is that the Detect plugin in Gradle creates an additional configuration, and you point it to the Maven artifacts that contain the rules, and then it knows how to load them and it knows to run them.
Yeah.
I don't know if it's something that maybe we could do in
we should. I
Lint
mean,
plugin.
honestly, I did the Gradle plugin some years ago, and I didn't, it was like, what does that meme about? Like, I have no idea what I'm doing. Like, that was it. Like, I just kind of cobbled a few things together. And, again, we get sort of the integration that sits in the Gradle, in the Android plugin is much stronger. That's why we have all the caching and all the modeling inputs and so on. So, yeah, it's probably somewhat limited beyond like just configuring lint to running on your own code. I don't know that it's going to pick up custom rules, but it would be good if we did that. I mean, I know we integrated with the service registry at some point, right? And I'm wondering if that actually just works. I'm not sure, so the way this works is that you put, the meta-inf file that lists this special lint API, and then you point to your own issue registry. And then that's how we're going through and loading these classes. So potentially if one was on the class path, should just work. I don't know. We could try it.
Could.
Yeah.
Who knows? Okay, so someone missed earlier the distinction between UAST and PSI. Can you just recap that very quickly before we switch to the code?
Yes. PSI is language specific. If you look at the PSI structure for, if you get like a PSI tree, it's going to be deeply tied to the Java world or the Groovy world or the Kotlin world. Like you cannot analyze PSI elements in a universal way and have it work. UAST is basically, it's a bridge. It sits on top of each PSI implementation and maps it to a single view. So if you basically implement your check by walking the AST, the UAST, it'll work for all of these things. And the key thing is it's going to make it look like Java, right? So if, like, again, the property example, right, or companion objects are mapped as inner classes, right? So it's just going to be the way you imagine Kotlin code is compiled down to Java or corresponding Java code. If it went via source, that is what you get with this UAST. So you can write your sort of single analysis, assuming UAST, and then it's going to work for at least Java and Kotlin. I think it would be cool if we had more languages. I don't think anyone's bothered, because I think at this point, I don't know if Groovy, is really something people are investing a lot in. But in theory, it could be more.
So yeah, the follow-up question there is, so writing lint checks in UAST is preferable, as it's gonna work for everything and should be easier to work with?
That's right. Like, most of our lint checks are written in UAST, because most of our lint checks are doing things that are API specific, not language specific. It's really only when you wanting to do something specific with a particular language, like, hey, in Kotlin, and you're using coroutines, don't do XYZ. Fine, you can do that in PSI, right? But almost always, for most of our lint checks, they're doing something where you could also call it from Java, and then you really don't want to have two implementations, right? Or sort of, or worse, only work for one language, and you have a blind spot for the other one.
Yeah. Okay, let's write a lint rule.
Okay.
Shall we? Do you want to share your screen?
All right, I'll click share entire screen. Okay, and then I'll hop. Actually, I'll turn my camera back on. I think that's what we discovered was the trick. Yeah, cool. All right, can you see my IDE?
Yes, we can.
Actually, that was not the one I meant to share. Let me share AndroidStudio instead. Okay.
It's a very, very secret AndroidStudio test.
Yeah, that was intelligible. Okay, so what I've done here is...
can I ask you to zoom in the IDE a bit? Like 125% maybe?
Yeah, what was that?
Just zoom. I usually do it from Command-Shift-A, that. 125 is probably okay.
Is that good, or do you want to go further?
Seems okay for me. I don't know. I'm sure someone will find it too small anyway. It's always the case.
150?
I think it's fine.
Yeah, last call. Yeah.
Cool. All right. So what I have here is I just basically pulled up the sample lint check project, right? So what this does is it has a sample detector and a sample issue registry. But I happened to look at your bundle app this morning, and I saw like, oh, you call URI.parse. And maybe we can have a lint check that basically tells people to rewrite this to using the Android X extension, for example. That seemed like, oh, that could be kind of a useful small thing, right?
Yeah, that sounds useful.
Cool. All right, so let's do that. So by the way, let's just show what's happening here. Is the structure is we have a checks project. This is where we put our lint checks, right? And then we have a library which bundles it, and then we have an Android app module, which is basically just consuming that library. And so what the sample check does is it just kind of looks for strings, and if it sees a string that contains the word lint, it goes like, hey, your code mentioned lint, congratulations. So it's a very, very simple lint, right? And so what happens is when we're running this inside the IDE, you can see we have, the lint running here, right, in the IDE. So that's kind of the current setup. So here now we're gonna make this basically light up, right? And maybe put a quick fix depending on time. Wow. How long do you guys go?
You can go over time if you don't have any other meetings after this.
Okay. All right. Okay. Cool. All right. So
I have an hour before my pizza arrives. That's the hard deadline.
That makes sense. Cool. Yeah, I haven't written this check before, so we'll just see how long it takes.
It's fine.
Okay. So we have a sample issue registry. This is basically just like registering our detector, right? So the concept with a lint check is that you create an issue registration. This is static data, right? Where you're basically giving an ID. This is what we're going to use for like suppressions, right? So if I were to go back into the IDE here and say, I want to suppress this, Alt-Enter, suppress, now it's suppressing the issue with that sample ID, right? So the issue ID is kind of an important thing. And then we can have a description and so on, and categories and whatnot. I think for convenience now, maybe we'll just reuse this class.
Yeah.
Right. But this time, instead of doing our own visitor, we're going to do something different, right? So we're basically going to look whenever anyone calls parse. So let me show again what the test method was. Like when someone calls parse, we want to basically look at that call, right? So basically lint is going to look at all the method calls, and when it sees something called parse, it'll give us a callback. So to do that, we do get applicable method names, I think. Yeah. And here we're going to say return list of parse. Okay, and that's no longer nullable because we know we're always going to call it. And when, let's see, now we're going to have like visit method, I want to say, method call, right? Okay, so basically here we're telling lint, whenever someone calls parse, invoke this callback. All right, let's do test-driven development. So we will go to the sample issue. Actually, surely we have a test here, right? Yeah, sample code detector test. Okay, we're going to change this to basically.
There was a close one. There was a close one to do live on Twitch. We surely have a test. It was very bold because
what could possibly go wrong?
Yeah, I mean, especially with me and Seb, that we delete the folder because that shrinks the Git repo.
Right. So I'm just basically creating a test file here, and we're just using Java now for fun.
Yeah, fun, you say?
Yes. URL. Okay, I think that's it, right? Okay, so we have our little test file here, and we know we're no longer going to have this match. All right. So now let's.
So you are literally using a string. So that's basically a string with the code inside.
Yep.
Yes. Basically, the way you write these tests you have these descriptors, right? So we could have also used Kotlin here, for example, right? There's a bunch of test file support. I actually think this is a great idea, and I think we'll get back to why later. Maybe I'll just preview it with by describing the test, lint can rerun your test under different conditions, right? So one of the things it does, for example, is it'll rerun this test and it'll insert parentheses in every valid place. And it makes sure that your detector still works, because it turns out that parentheses show up in the AST. They should, because they can be relevant for some refactorings and language analysis. But that means that if you're going hey, my first argument node, I'm going to assume is the parameter. Well, it could actually be parenthesis, and so your lint check has to account for that. And lint's test modes takes these descriptor files and repeats the test under a bunch of different conditions by mutating your test. So that's why we do this.
So would it also do things like if you have named parameters in Kotlin, it would just change the order to see if it still works?
Yes. I don't know if we'll do exactly that one, but for example, it'll rewrite every if to when in Kotlin.
Nice.
There's a bunch of them. The name parameter is a good one, actually. I should look into that. Good idea.
Is this turning into the feature request section?
Yes. And the other thing to notice here is that we're getting nested syntax highlighting, right? This is one of those nice things in IntelliJ. If I were to write, for example, XML here, so let me do res values strings.xml. Now I can, for example, create a resource file, resources.
Oh, nice.
And you have, now there's nested. You get nested syntax highlighting too, right? So it's an easy way to kind of look at your test and see them all in one place instead of having to open up a directory with multiple different files to understand what the test is doing. It's pretty easy to look at it. All right, so now let's run this test. So we haven't implemented the check yet. We just did our callback.
But we should see that it doesn't. Well, it should pass because we don't have anything being reported right now, and
it should hit my breakpoint, which is exactly what I wanted, right? So now we have we know that, actually, let me show you the node that we're being invoked on is this. It's the URI parse call, right? So again, in our test, we had a URI parse call. We've said we care about parse. Now this is going to call more than just URI.parse, any method called parse. So the first thing we want to do here is to make sure that we're really calling the right one. Code completion working pretty well. So if the method we're calling is a member of and I want to say, was it Android.net?
Net.euro?
It's this.
Yeah.
Right? If it's not the right one, just return.
So you need a false?
Probably
somewhere
missing a
there.
parenthesis.
Well, more parentheses.
Yes.
Yeah.
And also a exclamation mark, I think.
Yes,
In the
right.
if.
Okay, so, and
Oh,
just for
no.
kicks, we can evaluate this now and see if it's right. And it is, like we are called on the right method, so we know we're not going to return. So now we could just say context.report, and the issue is issue. This is the field that we have further down here, right?
Am I the only one that finds your autocompletion unbelievably fast? How the hell is so quick? What the fuck is going on? What are you running this thing? It's like some NASA. Jesus Christ! Yeah, bro, it's a CDN, right? It's always DN. This thing. Well, look at how fast is that thing? So I'm sorry. I'm just angry even. I know angry even, but that's.
Oh,
this is a StudioBot, by the way, doing the completion.
Yeah, I know. Yeah,
which we don't have in Europe yet.
Are you using Pilot? And then I was like,
that's why we're not used to it. We're not used to it yet, but we will.
So because we have the AndroidStudio Peasant Edition, and that's why it feels so slow. Now I see. Yeah.
All right. So let's see what happened here. Okay. So I basically ran the test, and again, remember that what I did in the test here is I just said I run the test and expect an empty string. That fails, obviously, but now I get what is actually printing out, right? And what I do when I do test-driven development is like I kind of run with the wrong string, and I go like, oh, this is what I'm expecting. This is the correct string, and I paste it in. Voila. Okay, that was now we have a lint check, right? And maybe we want to make sure that like if it's calling the wrong parse or whatever, public static void parse, you know, it shouldn't do anything here, right? Parse URL. Hopefully, if we run the test, it's still passing. It should not be flagging on this. Yeah, still good. So this is our sort of first lint check, and that was easy and fun, right? No.
Yeah.
I'm not hearing anything.
Yeah.
Cool. Right.
Because I'm trying to understand what's going on. So
it sounded like a rhetorical question, Tor. It was.
Yes.
Yeah. So let's go again. Let's just slow down a little bit. Like, so you see, we have a test file. We're calling URI the parse. This is sort of this is the positive test. We want to make sure that it's passing this and not passing this. We don't have any false negatives, right? We have a parse call, and so going back to our lint check, what a lint check did was it's saying. It's a UAST scanner, maybe telling lint, hey, I care about Java files and Kotlin files, right? And we're saying, call us whenever someone has a method called parse, then we'll have this callback. And this is where we're getting the method that was called and the call node, right? And we first make sure that it's really a method in the right class. And if so, we just report it. And the next thing we can do now is to actually add a quick fix.
Yes, right?
Let's do that. So the way you create fixes in Lint is like val fix. There's this method. And this is basically, we're going to describe a fix now, right? So we will basically say we want to do a string replacement. And we want it to apply to the range. Actually, we're probably not going to, I don't think we have to do this yet. So we'll just, instead, we want to replace the text. Let's say we want to replace the text parse. This is not correct yet. With, and then we want to, no, that was the Kotlin with to URI.
Good StudioBot.
Right, and then we just basically also send the fix in here. Right, now, if we run the test, nothing will happen because all the test is doing is making sure we're generating the right warnings. But we have another method on this Fluent API, which is expect fix diffs. And again, I'm just going to put an empty string in because that's how I like to do it. So now when we run the test, Lint is going to basically apply each quick fix and then sort of generate the diff before and after and put the diff in as the golden string. So if we look at the diff here, you can see it did this. Now this is not the right fix, to be clear, right? But it's the beginning of something, right? And so what we actually want to do with this fix is we want to take the parameter and we want to put the parameter first, right? And then we want to get rid of the containing class, and we want to get rid of and we want to move it like that. Like, this is the correct fix, right?
And I guess we also don't want the semicolon included in the thing that is changed, because it might not be at the end.
Inversion.
I'm sorry, what?
The semicolons there, I guess we don't.
This is showing.
Oh, that's just for this sample, right? Yeah.
This is just a whole line, which is basically just, and in fact, well, if we wanted to, like, I think this is still valid Java, right? So we'll do this if you prefer. No,
it's fine. It's fine.
I'm sure people are going to be really pissed off that we're making Java look worse. But
it's fine.
Yeah. By the way, no, it came up with its own description. Which is decent. But I mean, we can also just be explicit about it, right? So we can say display. Is it name? Name. Yeah. Use KTX extension function instead.
I see.
Yeah, we're kind of fighting the formatter here. And if we run that, you should see now that it's sort of putting in the description here instead. Oh no, we changed the format of the first part of the test. Right, so we took this out. Did we change anything else?
No, I don't think so.
No, we had some trailing space. Okay, let's try again. Yeah, okay, so now we have the right fix, and still our goal, we're not matching our golden file because we haven't actually made the fix correct yet. Okay, all right, so now we can go back to our detector and work a little bit harder, right? So we probably, we could just replace the entire thing and pick out the elements, and that might be the easiest thing to do. There are many ways we could go here. So maybe we could just replace the entire thing. And then we will take the argument, which we haven't created yet, and we will do this.
Okay.
And the argument source is going to be, wow, it's kind of close actually.
Jesus, are you kidding me?
I think I will just do source PSI text instead, but I actually like what it did. Let's try this.
So again, when are we getting this in Europe? Just out of curiosity.
You wouldn't be surprised to know that I'm asking that question pretty much every week.
Every week, yeah, I bet.
All I will say is that we're aware of this as a desirable thing. Okay, let's see, how close are we now? Oh yeah, we're basically almost there. We forgot to change our.
Right, yeah, the message.
Yeah. I like to line them up like that. And I think we have our quick fix. And actually, let's see now if we can get this working. In the IDE as well.
There's a question for you in the meantime, if you want, which is there a list somewhere that explains which methods are connected in the Lint APIs? So for example, calling get applicable method names, then calls visit method call.
Yeah, let me switch to my other IDE, which is in light mode because I was on the bus. I'm normally a dark mode person.
We know from the IO demos.
UAST scanner. So if you kind of look, actually, applicable methods. Oh, actually, oh, I went to the wrong place. Source scanner. If you look, if you look at the source scanner class, it's kind of documented here, right? So like going through this one and seeing what you can do, like if you want to, for example, be called whenever someone constructs a class. So if I call new URI, this will be the callback, right, to name a class, and then it's going to call back visit constructor, right? If you want to be called for any reference, so some code is mentioning something, get applicable reference names and then visit reference. There's special support for Android resources that makes it really trivial to be called back for like resources like r.layout.main. Superclasses, if anyone extends, for example, Android.content.context, you just do that and you get, again, a class declaration for a subclass. So there's just a bunch of different callbacks, which makes it super easy. And the annotation stuff is particularly powerful, right? Like if you want to sort of say, whenever anyone, whenever I'm calling something annotated with something, or combining, like if I have a plus operator and the operand is annotated, like implementing all of this stuff is very, very simple. So it's probably worth your time to look through the source code scanner class, because it's basically sort of giving you the detail. There's some deprecated stuff too that you can just ignore. That's kind of there so that we don't break stuff when we added new parameters. But generally, this is kind of, for UAST analysis, this is your best friend. And then there's some utility classes as well. Yeah.
They're saying thank you.
Cool. And then we had okay, let me see. We had a failure. It's a little bit tricky to trigger the update to make sure that it updates the bundle. I'm not sure what we're doing here to make it not build. Can't believe we changed this, but I wanted to see the lint check running, the quick fix running on the fly here. But to do that, I have to successfully be able to rebuild the jar file. I don't know what we broke.
Field failed on an exception.
Yeah. Is it possible that we will just like, hey, there wouldn't be to say about invalidate caches earlier? No, I don't know. I don't know what this is. So... Oh, well. Screw it. We're coming up on time anyway. But any sort of, is this kind of clear how this worked and how we did the quick fix and so on?
Sorry, you were saying, I was reading a message in the chat.
Yeah, go ahead.
These tests setup where you enter some sample source code and run the lints on, does this Android Lint custom rules repo have more of those? That looks super neat. I'd love to play with it.
I'm sorry, what was the question again?
So if there are other examples of the tests, like
I see, just like this one, like this setup here. Yeah, this is the main sample we have on GitHub that we kind of keep up to date with latest dependencies and so on. And all Lint actually has really good documentation. I will stop sharing my screen now before I open my browser. But there's a link that we can probably put here that is kind of useful.
I guess we can also point people to the sources of the lint checks in AOSP, probably. That will have tests, I guess.
Yes. Let me see. I'm trying to find how to share a link with you, because now I have too many tabs. Is there a chat here that I can paste something?
You can put it on Skype and we can.
There we go. I found it. I don't really know how to use Skype anymore. I put a link there. Yeah. Do you see the link I just shared?
Yes.
If you click on that, like, this is a very, very useful resource. I don't know if you can share your screen or actually I can share from here.
I can. Just give me 1 second and I'll open it as well, and then turn off your screen share and turn on my screen share, and yes. There you go. I'm not gonna share it with you on Skype because that would stop your screen share in case you need to show something else. But I'm just showing the content of the page.
I see. All right. So this sits under the namespace of the sample we just saw, but this is the documentation folder, right? And so issue documentations, like fourth link or so. This is basically a database of sort of all the built-in lint checks. And if you click on like libraries on the right, you can see we even index like the Slack checks, right? And you can kind of get more information. This is all extracted from the issue registration. And we do some bytecode analysis too to sort of figure out version compatibility. But that's more as a user. But if you go back to the main page again,
yeah, I was still there because I hadn't moved.
Okay, yeah. The issue documentation is kind of interesting, but the main thing I want you to click on is there's a whole second bullet that says documents for authors of additional lint checks, and it says complete book.
Oh.
If you click on that, you'll see this is a mark deep.
Oh man, the scroll bar.
It's massive, right?
Oh,
and this
wow.
is basically, I spent a few weeks kind of doing a brain dump on sort of all the tips and tricks people should be aware of. It is not a comprehensive guide to things like UAST, and that probably is, there's still use for that. But this one is going to talk about test modes. It's going to talk about how to configure your project. It's going to talk about concepts like analysis scopes. It's going to talk about quick fixes. Like if you want to write lint check, I think this is a pretty invaluable resource.
Wow.
And it's also going to link to the sample repo we just showed. So like this to me is sort of the canonical resource, if you're interested in this.
Oh wow, there's a
Sebastian,
lot of stuff.
Can you link the specific page that you're showing, just to save some click?
Yep. Give me 1 second.
Thanks.
Yeah. So the other links you'll find there is, there's also usage documentation, like how do I configure lint, the lint.xml file? What is its syntax? What are all the special system properties and environment variables you can configure lint with? Like there's some other documentation that is not for API authors, right? So there's several different focuses. Focusi? What's the Latin? You're Italians. What's the Latin correct plural of? No.
Sure.
Would be foci, I guess, but
yeah. Anyway, there are different documents for different sort of audiences, right? But this is where I would start, And if you see mistakes or glaring holes, let us know. And this is all basically just derived from our lint source tree. Like this is written as Markdown or Markdeep docs, right? Markdeep is a special dialect of Markdown that Romain Guy showed me. Like this is how they wrote their filament docs, and it's really nice. You can do ASCII art in the Markdown, and it like creates beautiful graphs out of it, right? Which is kind of cool. So I like it.
That's very
so
cool.
do you have a Kindle version of this thing, because it's huge? Can I have it as an audiobook by chat?
Yeah, that would be great. That'd be great.
No, you should totally read the documentation, Tor. Ask chat for tips on how to do audiobooks.
I feel like with all the podcasts we have done, it should be trivial to train an AI, right? To basically do it, and then also get it to insert all the puns that chat would come up with. We can really make a chat,
you want to automate chat? No, don't do that.
Well, like I said, there's so much training data that yeah.
Oh man.
I remember that's like the ultimate insult in the 90s. Like, I'm going to replace you with a small Perl script. That was like, that's what as good as it got. Yeah.
that's deeply
now he's AI. Now he's AI. Fair enough.
Oh, this was very nice. Very, very nice.
This is a lot of documentation.
Someone saying I see the Slack links in there too. What are checks are indexed there?
If you click on it, you'll see, and if there are other ones.
Trying to find it because I hadn't seen it.
Okay, click on the issue documentation link. Did you do that? Because I can't see your screen.
Yes.
Now at the top, you can see that you can sort by like
year, by vendor.
And yes, and there should be a libraries at the right, I think. Actually, let me check.
Yes, there is.
And that's the one.
Oh, I see.
That has the one, so there's Vanik Tech, he or she, I'm not sure, has written a lot of checks. There's some old Dagger ones from us out of this post. Slack is the one that's, really recently adding a lot. And if you click on the Slack one, you sort of see that
there are two of them. There's the compose and the non-compose ones. I'm gonna check the non-compose ones.
Oh yeah, the non-compose one. You can see on the bottom, like We also derive like a, version
Oh.
compatibility. There's like you can see for each version. This is all by just basically pulling down the AAR files and doing
Yeah.
bytecode analysis and
So
loading and checking.
is this a list that
So
you're maintaining?
It's
so
derived.
we can see your screen. So if you're sharing, Seb, we can see your screen
All
because I
right.
just
Yeah,
checked.
I had switched back to the non-showing screen.
No worries.
No, this
Okay.
is all derived. So there is, some code in lint, which is like the issue generator, right? Which basically walks through, pulls down all the AARs, instantiates the issue registries. And so like one of the things you'll notice if you click on one of the built-in checks, it has links to the corresponding source and test, right?
Oh.
So it is, and it also tries to include examples, and it pulls the examples from the unit tests.
What the?
Yeah.
Oh, sorry. That's impressive.
And so there's a naming convention that I was just telling the Slack people about. Like if you name your test documentation example, that one wins, as opposed to otherwise you'll just pick one, right? So most lint checks now, you do one that you try to keep it clean. You're just showing like a very good example. You're not including all your false negative tests and all your false positive tests. Like it's the one that's kind of showing a good example. We'll use that for documentation, and then you put the rest in some other one, right? So yeah. Anyway, so this is derived. So, but it's not continuously kept up to date, right? Like I have to, because MarkDeep has the HTML extension.
Yeah.
Google's like Git viewer refuses to render those as HTML. I guess it's a security issue, right? So like you'll just get the markup, right? And so that's why we copy them over to this GitHub page for the sample project where we can host them. But that requires us to like go and like pull them out of the lint repo and do this, right? So it's not like the second Slack, for example, updates lint check is not going to show up here, right? It's going to be like once a month or whatever, when someone takes pity on the registry.
So if someone creates a nice collection of lint checks, which they should, how can they get their checks listed here?
Either ping me or, pull request on lint or file an issue maybe, right? Like the main thing should be that ideally they should be of general interest.
Yeah, of course.
Right? Like, because there's a lot of custom ones. I mean, I did basically trawl through Maven Central, sort of searching for lint in the code name and looking, and I found some that seemed very, very niche, right? And so I didn't include them, and I wasn't sure. Like, I also, like, I found some from a company that seemed to have stopped working on them. Right. So if they're stale, I thought, wow, okay, maybe not so interesting then, because they're gonna sort of not stay up to date, right, with API changes. But if they're like actively maintained.
Would you include things like, because I see, for example, that there aren't, oh no, there is timber at the end. So if you have a library that contains lint checks and it's a, I guess, well-known enough library, then...
Yeah, that's the only thing. Like I would like to avoid this being everyone's hobby project. So it becomes a very long list and you kind of have to search for the big ones. Like I would like this to be stuff that has users and so on, right? Initially, just because, and it's difficult to like a store registry for lint checks and apply editorial control, right? So just kind of use your good judgment.
Then you have to deal with the EU's DMA and stuff. No, you don't want that.
Yeah. The other thing is that like lint checks are kind of running with credentials, right? Like they're running.
Yeah.
Like, I don't know. I don't want to make this a malware vector.
Absolutely. Yeah.
Yeah. So yeah, I kind of want to keep it limited. So it should be for like well-known open source, or actively developed, and there's some trust involved, ideally.
Yeah. So say, for example, Square comes up with the lint checks for retrofit, then that would be a sure. I see. Cool. I think we're out of time. Never out of topics to discuss.
I know. Yeah.
But this was super interesting, Tor, because I thought I knew lint. I didn't fully know lint, turns out. I know some things about lint.
and there's more to know. So, hopefully your viewers can look forward to episodes 2 through 12, as we sort of continue this journey.
Would love to have you back anytime.
Cool.
And I don't know if there is in the future some new stuff that we are working on that we launch and you want to come talk about it, you're obviously more than welcome to.
Cool. You froze for me for about 5 seconds. I was afraid that the connection was stopping, but yeah.
you froze as well. What I was saying is that if there's anything that we are going to be releasing in the future that you want to talk about, you're always more than welcome to come.
Cool. Yeah, I mean,
It's
even though I always talk about lint, it's kind of like how I still do a little bit of coding on it, you know. But like, there's so much stuff in Android Studio that I would love to talk about.
Yeah.
You know, and so like,
so would I, because I know
Yeah.
that there's a lot of things that you just don't know about. Maybe get a passing mention on some release notes or something, but then it doesn't really explain how much complexity and work there is behind those things.
Absolutely.
And we end up kind of taking a lot of things for granted, like indexing is a good example.
Yeah.
But there's so much behind it to make it work the way it works, and to make it not just terrible.
Yes.
Because that's the risk, right? It's you can have amazing sounding things that just don't work.
Yeah. Yeah. No, software engineering is hard. Who knew?
Who could have figured? Let's make sure that we make an episode on Gradle, and we get Chet to come and just complain about things.
It's probably not fair to Gradle. You know, there's a lot of like joking about Gradle, but we also know from our customer advisory board that like people also love Gradle, right? Like it is extremely powerful, especially people who were there in the before times when it was the Eclipse build system and Ant, and you know, procedural programming in an XML file was just, you know, with like shelling out the jar files that were trying, like it was kind of a nightmare. And so some of the things, you know, that you can do now, like even just the way you configure lint, I'm going to bring it back to lint, right? You know, the nice DSL and configuring your CI system and having it run and download the dependencies on the fly, it's pretty nice.
Yeah. My impression is that people that complain about Gradle have mostly only ever used Gradle.
Well, there's a I don't know, I did not come up with it, but it rings true, and that's like the best build system is the one you're not yet using.
Yeah.
Right? The grass is always greener, especially for build systems.
Yeah, it's, you know, I've seen applications on iOS build faster. I'm like, well, maybe a sample.
Yeah.
I'm working with iOS lately on a pet project, and I also tweeted it. I will never complain about Android ever again. The Play Store, the Gradle file, the Gradle builds, don't. I mean, try out iOS. You know, starting with the 4,000K, you know,
I'm not going to say anything about iOS, but I will say that, you know, like in the, you know, with Android, you know, we are sort of being able to take a lot of great practices, you know, in terms of like, you know, Maven libraries and build on top of it, like the AR abstraction and so on. I do feel like we have a compelling developer experience, you know, could be better. We're aware of our bugs. We're still working on them, right?
Can always be better. But everything can be better.
Yeah, but like last summer, I spent a couple of weeks, you know, there was no meetings week, and I spent a couple of weeks just building an app and finally learning Compose and so on. I was like, wow, this is, you know, and I was using the resizable emulator. I was using Live Edit. Like I was basically kind of using all of it stuff and StudioBot, right?
Yeah.
And it's like, wow, this is really kind of coming together here. I like it.
There are some things, especially around Compose, because I tend to do Compose for desktop most of the time when I do Compose. And when we do the streams and we use Studio and I have Live Edit and I have the previews that works, I have the layout inspector, like all those things, you kind of take for granted when you have them, and then you don't have them anymore, and you're like, oh, so that's how it would be.
Yeah.
Makes you appreciate the tooling you have when you don't have it anymore.
Yeah, absolutely. Cool. Well, it's been a pleasure.
Cool. Thank you very much, Tor. It was
ciao,
very,
is that what
very
we say?
good. And maybe there's someone saying that we should have a stream about Gradle caches and remote caches.
That would be.
We need to.
The AndroidDev people have done some stuff too, you know, with caching, and I know there's like the whole, you know, the Gradle enterprise thing, and there's a lot of interesting stuff. I'm the wrong person for that. I don't know anything about it. But yeah, we should absolutely get people on for that.
I can try and reach out to someone at Gradle as well. I think that'd be interesting.
Yeah.
Tor, thank you very much.
Thank you.
I'll talk to you soon. Have a great one. Bye. Thank you, everyone. See you in 3 weeks. 4 weeks? 3 weeks? Yeah, on the 3rd of April, we're going to have Ben Weiss and we're going to be talking about text optimizations, hopefully. Have a good one. Bye.
Ciao.